All right, so let's look at how we would calculate the surface area of a solid that is composed of different solids that we're already familiar with. So if you're looking at the picture that I drew, it has two different solids attached to each other. So if you look at the top, you should see a cone, and then at the bottom, you would see a cylinder. So if we're trying to figure out the surface area of this shape, you should be asking yourself what parts of the shape would you be able to touch, because it's not as simple as calculating the surface area of the entire cone plus the surface area of the entire cylinder. You have to have a little bit more thought process and awareness as to what parts of this shape you can actually touch. So on next slide, I have this video here of our solid. So I drew that picture and it represents this same shape here. So if we look at this, this would be what we would be able to touch, the pink part, right? This is my solid. Now, I just have the cone on top of a cylinder right now, but I'm gonna remove it and I'm gonna show you the parts that we would actually be able to touch. So the pink represents the surface area of this entire solid place, or the entire solid shape. So if I separate it, what do I notice right here? So if you notice, it might be a little bit hard to see, but I don't have anything on my cone right here. The circle part is missing, and it's missing because it's not something that we can touch. So if I take out and look, this is the only part of my cone that I have, okay? So that's only looking in terms of the cone at the lateral surface area. Now let's look at my cylinder. So for my cylinder, at the pink part, we have my lateral surface area, but I also have my circle base at the bottom. So when I'm thinking of how I'm going to calculate the surface area of this entire shape, I have the lateral surface area of the cone at the top, and then I have the lateral surface area of the cylinder, but plus one circle. Okay, so now let's take that into consideration when we start calculating the lateral surface area of our solid. Okay, so here we are back at my my picture. So after looking at the images that you saw in the video, looking at the real life cone and the cylinder, we saw that we're only going to be looking at the lateral surface area of the cone. So if you look at the formula for lateral surface area, we're multiplying pi times the radius times this L, and that variable represents the slant height of my cone. So when I look at my picture here, I have a radius of 2, and I know that this vertical distance of the entire solid is 13. So if I subtract the 5 from my part that's a cylinder, I'm left with 8 right here. That's the height of my cone, but that's not my slant height. So that's something that we're going to need to take into consideration when we try to solve. So this first part of my formula represents what we would use just for the cone. So then I'm also going to have to include parts that are looking at my cylinder. So for the cylinder, I have my lateral surface area, which is 2 pi r times the height, because we're looking at the circumference of that circle base times the height of my cylinder, plus just one circle. We're only adding one circle, the area of one circle, because when we were looking at our solid, there's only one circle that we would actually touch, and that's this this circle down here at the bottom. Okay, that's the only circle that we would be able to touch. The circle that is connecting the cone and the cylinder, it's not something that we would actually be able to touch, so it's not going to be considered part of our surface area. So let's start plugging in some of the numbers that we have. For our cone, we know that my radius is 2, so I'm going to multiply 2 pi, and here we need to calculate the slant height. So what are some things that we can be thinking of? I would notice here that I have a right triangle, and I'm solving for the hypotenuse, right? So this is my slant height. My slant height would represent the hypotenuse on my triangle. So if I follow the Pythagorean theorem, I would have a squared plus b squared is equal to c squared, which in this case, c squared is my slant height squared. So when I add these, 4 plus 64, I get 68. So that means that my slant height is going to be the square root of 68, because here we had the slant height squared, right? So to undo our exponent of 2, we have to take the square root. So for my L, I'm going to put the square root of 68. And now let's add the information from my cylinder. So I have 2 pi, my radius, which is 2, and then the height of just the cylinder part is 5, plus 2 r squared for that one circle base at the bottom, so that's 2 squared. So now let me see if I can simplify this a little bit further. I have 2 times the square root of 68 times pi, plus 2 times 2 is 4, 4 times 5 is 20, so that's 20 pi, plus 2 squared is 4, so this is 4 pi. And then I can add the 20 and the 4 pi to get 24 pi. Now this other part, because it's connected to the square root, I cannot add this together to get 26 times the square root of 68 times pi. It doesn't work like that, because the square root of 28 makes that an irrational number here. So we're just going to leave our answer like this, and this is surface area, so this would be square units. Or if you want to go ahead and plug that into your calculator, so let me give you a roundabout of what this would be. Square root of 68 times, and I'm going to use 3.14 for pi right now. So I have that my answer is close to about 127.146, about square units for the surface area. All right, I hope that was helpful. When you're calculating the surface area of a solid that is composed of other solids, you really need to pay attention and ask yourself, what parts of this shape could you actually touch?